we have to finish this lesson today. This is, you will find that our lesson today is a kind of revision. With a little bit, we can say, some spices and some changes, which is a minor changes, by the way. It's not a serious one. The word kinematics means it's the science that concern about description of motion. If you want to describe a motion, you have to use some words, just like time, speed, velocity, acceleration, direction, distance, particle. So these words, now the set to describe all these words and how these words they are related, we use what we call by the kinematics. Okay? First of all, we will speak about the motion. This is in front of you. Now I'll wait for the computer. But the motion simply, الحركة, is a change in position. If you just simply shift from one spot to another, that means you are in motion, right? And there's one more thing. If you change also direction, if I'm just, for example, looking to the back wall, and then I shift to the left here to the front wall, I'm in motion because I've also changed direction. So either if you have changed position, you are in motion, or you change direction. In the textbook, they mention orientation. It is the same word, by the way. Orientation معناه تحديد. So this is the same thing. So you can simply claim that you are either in motion if you change the position or you change direction. Okay? Now, we will start with this one. I'm sorry, we lose always time, 5 to 10 minutes waiting for a computer. Every time.
The other class might have an already working computer. It might be faster processing.
Inshallah, we hope so. Inshallah. But today we have to manage here. We don't have other classes. Okay, alhamdulillah. Okay, now this is the first one you should know. I want to say something. There's also in physics, we use something called by the motion diagrams. Now the motion diagrams, let me just here summarize it for you. This is, by the way, I'm 100% sure that you took this before. Motion diagram is simply show the object at different time intervals. Okay? And to draw the object, you don't have to draw the original object. You just simply draw a dot. Nokta. This will show you the object, and you can describe its motion from here. What is the rules? If we have a dot like these, as an example, the rules mentioned here that the time for between two and six dots is always second, 1 second. This is always constant. That means time here 0, then time here 1, time here 2, time here 3, time here 4, and so on. So if you measure the distance between these dots, this is the same distance. It's not changing. So yes, we can say simply this object move at a constant speed.
The solution is 0.
Yeah, I'm not saying we will see. Okay. Now let's talk about the other thing. If the space between these dots actually increasing gradually, just like this. You start from here. I'm not going to write this anymore. So this is here, then little bit bigger, then little bit bigger like that. So look at the distance now. The distance here was short, then become bigger, more and more. How we describe the motion? Yes, speeding up. Okay, accelerating or speeding up. Now this is clear because it covers more. And did you know something? The time is the same. This is t0. This is 1, 2, 3. Always the time constant, doesn't change. What the change actually? The distances.
The distance. Yeah.
And finally, we have the last one. If you start like this, then move like this here. and you can easily claim that. What about here now? What happened? The accelerating or slowing down. By the way, I'm not mentioning the acceleration because we will have it later. There are many things related to it. This one here, gentlemen, if we draw it, it's very simple for us to use these instead of drawing real things, right? So this is how we use the physics to describe the motion. Now you will have an idea also with me. I will show it to you and we proceed. No, don't worry about the access code. We will provide it for you. Because I see all the new books, even new book, there is no access code for it. We asked the publisher to provide this. So we are waiting. Okay. Now I need to tell you something. At the beginning of your slides, always there is in the first page. Yeah, we will wait for it a little bit. We have what we call by the learning outcomes, you see, or objectives, and that it does. Of course, I will read it for you today. This is pre-lecture actually material, something you can go through with some videos related to it. But here, this is our objectives of today objectives. For example, in the first objective, we have to describe the motion diagrams. Then we have to recognize quantities. This is your task for the next, all the lectures, you have to go through it. You should know what are the points that we have to cover every week. Because honestly, 15 minutes a week is very short for us. You'll notice this today. By the way, we try to finish one chapter sometimes in 1 hour, one full chapter. So we try to, you know that, yeah, to move a little bit faster. Okay. So let's proceed now. It's open. As we said, this is here the objective goals of the lesson, and we will start them. Processing. Okay. I need to show you a question. Just like what we finish it now. Okay. Out. Okay. What is the motion? We said the change in object's position or orientation with time. Okay. Now, motion diagrams. Follow me, I will explain this. Showing an object's position at several equally spaced instants of always the time is equal. Always. 1 second between two successive dots. Now, just like this one, from here to here, we can say that objects moving at lower speed, and from here to here is at a higher speed because the distance more. But the time is the same. If you say, how much the time here? If this is 0, this 1. If this is 0, also this is 1. This is 1 second and this is 1 second. Since here, the distance here is shorter than this one, so this object is faster than this object. Is that clear? Now, I will ask you this question. We have 3 motion diagrams. Look at here, gentlemen. It could be also what? Vertical, like that, or horizontal. I will circle it for you. راح اضل لكم اياها عشان تعرفوها. Now, question 1. Which is the dust particle settling to the floor at a constant speed? Yes?
B.
Why?
It's going equally, like 0 to 1.
Yes, this is what I'm looking for. They are equally spaced.
Yeah.
So this is constant speed, okay? Now let's go to the next one. Which is a ball dropped from the roof of a building? You should justify your answer. Yes? Why?
Because the distance increased.
Why the distance increase?
Speed.
Because of
Speed.
Why is it moving faster?
Because
he knows, I'm sure that he knows.
because the gravity
Yes.
fall.
When you drop something, what happened? It's accelerating due to the gravity, صح? That means when I say accelerating, I mean its speed increases. To show that what happened to the space increases too, right? So this is what I mentioned last time. I will take back to you here. Please, يا شباب, you should know the idea. And in the idea there will be many questions. Don't worry. The same idea. You should always trust yourself that I can easily justify it. The same question I can give you, but instead of a dropping ball, can I give you, for example, if a ball is actually projected up, so what happened to its speed?
Increase.
So this would be C. Oh, many things, just like that, okay? Right. The third one, to proceed, which is a descending rocket slowing to make a soft landing on Mars. Descending متباطئ. Yes, يا شباب, it will be C. Is that clear for you?
Yes.
واضح يا شباب لكم؟ Okay. Again, when you read these, expect something. I can, instead of using gravity, I can use a friction. If I kick the ball, it will travel. Then what happened to its speed? Slower due to the friction, and it will stop completely, right? Which one of these? Only
C.
the
C, yeah.
You can measure like that. This is how we work. Instead of dropping something, I can give you due to the friction, I can give you due to the anything else, and you should just link with it. The idea is the same. We said it. نفس الفكرة لكن أسئلة مختلفة. مختلفة الأشكال. طيب. Let's go to the next one. Now when you talk about the position. Pay attention, gentlemen, here. When we talk about the position has significance, تمييز. To know the position, you should know three things. You should know the reference point, distance, or direction. Let me explain this for you. If I say, for example, I'm here in this room, I can simply tell my position in many ways. I can simply say, I'm 1 meter from the back wall. I'm 2 meters from the door. That's correct. I'm 4 meters from that wall. I'm 3 meters from that wall. All of them correct, right? Can I say, for example, I'm at 1 meter and your friend is at 5 meters?
No.
We are sitting actually sit beside each other. احنا جنب بعض واقفين. كيف أنا واحد هو 5? By the way, this is correct, but I'm 1 meter from that wall and he's 5 meters from that wall. So, to make equal, fair measurements, we have to specify الله يبارك نقطة المرجع يا شباب. If I say from the door, if I'm 5 meters, he's also 5 meters because we are close to each other. صح؟ احنا واقفين جنب بعض. لكن here we have to mention the reference point. نقطة المرجع, from where you start. So, to know the position, you should know the reference point. You should know the distance and the direction. Of course, direction I will explain. Now, I just explained this in another way. I will show you something. Sometimes we use a ruler. You know that ruler, we use it here. It has some calibration like these. Okay? Now, I will show you another idea how to use the reference point. Sometimes if you have a strip, any kind of strip, you just put it here like this. How much the length of that strip?
2 centimeters.
It's 2 centimeters. Okay. If we put the strip like this here, now how much is it? Is it 5?
No.
How much is it?
2 cm.
It's 2 centimeters. In the first one, look at me here. Your reference point was 0. We are not mentioning it. It should be 2 minus 0. But always we skip 0 because it doesn't change. In the second point, my reference point is reference point is the point that where you start measuring. النقطة اللي بتبدأ فيها القياس انت يا شباب. صح؟ This is the idea. This is, you start from 3. So now we say, it's 5 minus 3, which is 2. Like this way. So this is what's in physics we have very, very important thing. That, for example, the ground for the gravity is a reference point. Sea level for altitude is a reference point. لما تقول يا شباب ارتفاعات في المناطق، كل ارتفاعات المناطق تقاس بسطح البحر، صح؟ مستوى سطح البحر. هذا الريفرنس. والله ما بقدر اقول منطقة مرتفعة ومنطقة منخفضة، إلا لازم يكون عندي منطقة أقارن المرتفع فيه والمنخفض فيه، صح؟ Okay. Let's go now to the problem. We have a distance and we have a direction. Suppose, gentlemen, here we have in this graph, we have this post office or house, and from the house here we consider it as to be the reference. He considers 0. This is my reference point. Now the car is moving from that house to the right. Is moving plus 4 kilometers, as you see. And the cow here, as an animal, is moving from the post office to the left. We consider to be minus 5 kilometers. Now, why we use here signs? Because we have what? Directions. In your textbook, gentlemen, you have to be careful. Right always positive, left always negative, up also positive, down. It's simply always we use these notations. You have to stick with it. لازم تلتزموا فيهم يا شباب. أي حركة, all to the right is always positive. To the left, negative. So this means, now this means here, it's either right, هاي تعني right, and this means left. So if I say, for example, the cow is moving minus 3, it means 3 kilometers to the left side. أو ممكن 3 kilometers down. Okay, شباب? In this way we talk. So this simply, now these signs shows only direction. Shows only direction, not more than that. Why we need direction? Because they now, later you will know that we have something called 5 vectors, متجهات. And to know the vectors, we should know the direction. We will have it. طيب يا شباب, see. The other example, here we have it. We have the displacement. The word displacement is different than distance. Distance is a different word. Simply displacement, yes?
Displacement is when you compare the initial point and the ending point. So you can, rather than distance, distance could be, you can go from your point and then come back to your point.
Yeah.
The distance can be 10 kilometers, but displacement is a...
Allah يبارك فيك. Yes, right. I will make it simple here. He will say it. Displacement is nothing but a change in position. I will explain it here. Change in position. When we talk about straight line motion or linear motion. لاحظ يا شباب. If you start from 0 and you end up at 120, your initial position was
0.
Your final position. So your displacement is 120 minus 0. Okay? This is the idea. Now, this displacement we will have it later. It's a vector quantity. اسمها إزاحة. Displacement is different than distance. And distance is actually to the length unit that we measure. تهتم يا شباب كم وحدات الطول؟ يعني أنا مثلا كم خطوة راح أمشي؟ طب أمشي روح رايح أي اتجاه تصمت عد كم خطوة مشيت. While displacement is mean how many actually length unit you displace from your original point. كم يا شباب كم وحدة أطوال أنت أزحت لما when we say إزاحة من from your initial position. Okay? So we will have it. So this is now the I. To know this very clearly, we should know what we call by the scalars and vectors. Now this is, I prefer you to, all of you to just pay attention. You will copy this later, but you have to know. See, we have all the physical quantities could be either scalars or vectors. Scalars, that mean the quantities that have only magnitude. So I will write only simple words, only magnitude. Magnitude means only size, only quantity, مقدار فقط. ما في غيرها. Now, in case of vectors, we have a magnitude
And direction.
and direction. Barakallah. Plus direction. Now I will tell you some things to compare between these. I know there are many examples on these, hundreds of examples. And I need to tell you something. We have, for example, distance is a scalar. We just draw it like d. We have something close to the distance is called by displacement. Yes, d with an arrow above it. You should notice something. Both of these measured in meter. But this is scalar and this is? Yes. I will give you another example. Then I will give you something. Now we have also speed and we have velocity. Now speed also measured in meter per second, and this is meter per second. We have many examples. We know the time, mass, volume, blah, 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 a lot of them. I need to show you something. Sometimes this is confusing for the student, but it's not. When you say speed, you concern only about the number. That's why in your car, the speed meter gives you the speed. Only the number doesn't give you the direction, right? When you say velocity, if you ask yourself in English, why are these two totally different words? For English people, when they say velocity, they expect direction. Yeah. If someone asks you, what is your velocity? You can't say my velocity is 20 meters per second and stop. Since he asked you velocity, you must mention direction. You must say north or south or something. But if he asks you, what is your speed? You say 20 meters per second. Then stop. It's okay. If he asks you what is your velocity? You have to mention the speed and the direction. Okay? There is something very important I need you to notice. Gentlemen here, always the scalars positive or zero. So I will write this for you. Always positive or zero. Here, this could be positive, negative, or zero. This means if you have a negative value, this negative value is, we are not talking mathematically, we are talking about direction. If we say, for example, the displacement is -5, it means the displacement to the left. It's 5, but to the left. If I say, for example, velocity is -50 kilometers per, means velocity 50, for example, downward. Okay? So be careful. Always this is positive and this could be positive or negative. Okay, let's proceed now. Of course, there are many details. That one we will have it. Okay? Sorry. We mentioned that. This is a change of position, and we have the time is also 6 seconds. This is the idea. We proceed. Look at this example. This is very important because this is what we face. We have two objects moving. We have a car, we have a bicycle. Can anybody tell me what is the comparison between these two? Motion. Which one is moving faster? Which one is moving slower? Yes?
Car is moving faster between the 1 second and 2 seconds compared to the bicycle.
Yes.
Speed.
Why? Okay, why you say that the car is moving faster?
The distance grew between the
Yes. The distance from here to here, how much is it? It's 40. right? It's 40 feet. What about the distance here? So the car travels 40 feet in a second. The bicycle travels 20 feet in a second, so the car is faster than the bicycle, okay? Now I'll give you another example. This is how we should actually translate the graph. Leave this. We have now two bikes. We have bike 1 and bike 2. Who can tell me how we compare between these two? Yes, Fran?
They have the same speed, but
Yes.
direction.
Same speed but different?
Velocity.
Yes, barakallah feek. Wallahi, this is what I'm looking for. That's right. We have the same speed. You agree about this? Yes. Same speed is 20 feet per second. This is 20 feet also per, but different velocity. When he mentioned different velocity, he means different directions. Yes, different velocities that we have. Okay. Now we have the speed. You studied this. This is distance over time. And we have also velocity. We can consider as velocity is equal to displacement over time. I have an idea before we proceed. Speed and distance are both scalar. Here, velocity and displacement are both also scalars. You cannot switch these. So you cannot say, for example, speed equal displacement over time. This is wrong. Yes. No, it's velocity, right? Why? Because speed is scalar and displacement is vector. You cannot mix scalar with vectors. Always. You can use the displacement with velocity because both of them contain the direction. While with the speed we have to use what? A distance. Time is always time is always scalar.
Okay,
It's important. See, time you can take is not related. Time we quantify is actually independent variable. It always exists. We make it just like something to balance the equation. But any change in this one will affect this one. Time is always constant. We agree. This is always, see, this is second and this is second. So all the same, right? So what we concern about this one. This is the hybrid. Okay. So far I think these questions are very, you feel cold and شايفكم هيك تعبانين مالكم. طيب يا شباب الله يعينكم بسيطة صح. ان شاء الله الاسبوع القادم ترجع لكلاسكم تكونوا انشط من هيك. شكلكم بردانين. Okay. We have actually 3 tables here. Please, you should know that the first table and the second table, you should know. First table we talk about the SI units. انتوا بتعرفوهم. Second for time, meter for length, and kilogram for mass. The idea is what? If you have any one of these in other form, you have to convert it. For example, if I give you the time in hour, in for example day, in minute, you should convert to what? Seconds. This is by default. Don't even think. You should know it. Nobody will teach you this one. You already studied this in later years. Now, meters, you have, so for example, we can use kilometer, we can use centimeter, and blah, just like this. Now, this is you should know. Now, the prefixes also you should know. We have mega, kilo, centimeter, millimeter, micro, nano. Is there a problem with that? Also, you should know it. Now, the last one, don't care about. This will be given for you in exam. The key for it. This is the American units, where they use inch, feet, mile, pound, just like this. This will be give you, actually, if there's any question on these, we will give you the key for that. But these 2 tables, you should know it perfectly. Okay. Now, this is the vectors that we already. Look at me. I want to say something before. In your exams, there would be no type of definitions. Nobody will ask you to state definition or to mention it. So when you study something, stick that any concept with a word. For example, if I say scalar, you say, oh, magnitude only. If I say vector, you say magnitude and nobody will ask you to find, oh, define, state what we mean by vector or by scalar. ما راح يسألك أحد تعريف. Only what we have only to know the idea. For example, here the scalars, see, we have a time, temperature, mass, distance, speed. I'm not saying actually, if I say, I can say 100 of these. Now the time, this is the symbol. This is actually sometimes D. I need to say, distance we have D. In vectors we have what? D with arrow. In your textbook there is a bold D. تعرفوا البولد موجودة في الكتاب. البولد معناها فيكتور يا شباب والعادي معناها ايه؟ سكيلر. That's it, nothing more. Of course this is all of them. Even they have the same ideas, the same units, but they have different examples. Of course don't expect, nobody will ask you this is scalar or vector. يعني هذا السؤال ما راح يجيك لكن راح يسألني some question. سهل هذا السؤال كثير. اوكي؟ طيب يا شباب. Now we have a distance. So distance is the length of the actual path traveled between 2 points. As your friend he mentioned, if you start with a point and you move in many things, you just count how many length unit you travel. This is your distance. Distance doesn't depend on the direction. While the displacement depends on direction. So displacement should be always straight line. Did you know why? Because you studied in math that the shortest distance between any 2 points is the straight line, right? So displacement always a straight line. Displacement. Why the distance could be nothing. Now let me give you an example. For example, if we have an object start moving from A, point A, he moves to the right, travels 100 meters to point B. Okay? Then he returns from point B 70 meters to the point C, as an example. This is 70 meters. In this situation, the distance is going to be 100 plus, which is 170 meters. Is that clear?
Yes.
Because all of them positive. Now, the displacement.
100 minus 70.
Yes, I will make it clear for you. Is 100 plus negative 70. Let me just explain for you. This now from A to B, they are moving to the right.
Yes.
To the right is
Plus.
plus. We agree about it. From B to C, we are moving where?
Negative.
So it is. So we say 100 plus negative 70, which is, by the way, is 30 meters. But we are not done yet. We have to mention
The direction.
direction. Please follow with me here. Always, gentlemen, we say that the object displacement vector is drawn always from initial position to the
Final.
not from final to initial. So my here, the direction is going to be from A to C. This is my displacement. Yes, this is my displacement. So you can write, you say this is plus to the right or east or whatever is it. Okay? Since it is a plus, it is means it's to the right. Okay? You can change the following. I will show you something. If this is, we just make it like this. Now it will be minus 100 plus, so it is minus 30. Minus 30 means to the left. Is that clear? This is here. That's why sometimes you expect in vectors we have positive or negative. Okay, Shabab? Now, if you start from A to B, then return back to A again, your distance,
Would be 200.
yes, your displacement,
Zero.
بارك. واضحة؟ طيب. The last point here. Sometimes the vector, we can show you, to draw the vector, we use arrows. What happened? The arrow here, it has 2 points or 2 parts. The head of the arrow, it shows the direction, and the length of the arrow shows the magnitude, المقدار. That means more magnitude, more length. And this magnitude means less length. And here the direction will be show it here. The head of the arrow will show me the direction. Yes. Sometimes we have the following. If I say the following, if I give you an arrow like this, and I write this is 5 meters per second. Now, can you tell me this is speed or velocity? Yes, it's velocity. Why? You have a magnitude and
Direction.
direction. Okay, if I remove this is speed or velocity?
Speed.
Barakallah. You should know by yourself when I draw it. Again, if there's a direction and there is a magnitude, this is velocity. If there's only magnitude, this only, here we have all speed, not good. Okay? طيب. Now I need to tell you something. Sometimes any vector you can draw it, we'll have it now in the form of an arrow like this one. Sometimes the vector you can just simply flip it. If you just write negative A instead of A, you have to change the direction. You just flip. اعكس. If you write 2A as an example, you just double its size. يعني عندنا هذا ال A مثلا 1 unit، هذا تعمله انت ايش؟ 2 units. 1 2. This is 2A. إذا كتبنا for example minus 2A, the same thing, but you just flip what? The direction just like that. So this is we have it because we should know now here almost how we draw the vectors and how we just connect it with them. Okay. Honestly, now we start the important things. And we almost done. تقريبا خلصنا ما في شيء كثير. أنا آسف يعني شايفكم مخدرين. طيب يا شباب. ترى يعني شايف حالك هيك حابب توصل دورة المياه تغسل وجهك، هذا روح اطلع ما عندنا مشكلة. المهم انكم ان شاء الله تكونوا مصحصحين اهم حاجة. حلو ان اول المحاضرة كويسة يعني ما هي معلومات قوية كثير. اما المحاضرات الجاية بتكونوا مصحصحين، زميلكم هذاك نايم تماما. شكل وجهه من هاي. طب انتبهوا يا شباب، احنا يعني بنقدر ظروفنا الله يعينكم يعني ما بنكر هذا، لكن لازم تنتبهوا على حالكم، لازم تاخذوا قسط من الراحه في البيت، تيجوا مصحصحين هنا. شفت نفسك مثلا جو بارد، جيب لك جاكيت يا اخي، جيب معك حاجه يعني قدر ظروفك. طيب يا شباب. Today we talk about here vector addition and vector subtraction. This is very important questions. How to add these two vectors and or how to subtract. Suppose two vectors will be given for you, okay? And your job is to find A plus B, their addition. What we do, we have a rule that we followed before. It is called by tip to tail rule. سمعت عنه يا شباب الرأس بالذيل. Yes, for vectors. Tip or head to tail. It means simply tip with the first with the tail of the second. Tip with the second with the tail of the third. And so on, just like that. You just stick them tip to tail. Now, if we want to find A plus B, this will be given for you. You have two options. Either send A here, tip to tail, or send B where? Here. I'm gonna do both of them. انتبهوا معي. First of all, I will send B. I will just simply send B here. لحظة يا شباب. I will draw B for you. Now this is my B. Now this is tip to tail, right? Tip with the first with it. Now the addition will be a vector. Start from the first point initial to the final. So this is my A plus B. Okay. Somebody else said, oh, doctor, I will use A. I will send A. Okay. Send A here to the other side. So this is your A. Now, you're actually here. Your summation will be B plus A. By the way, B plus A is the same as A plus B, because you know that addition is commutative. Okay. Now this here, this vector is the same as this vector. So you have the option. Always, this is very simple thing. Okay. Now, let's talk about subtraction. I have suggestion here. I need to tell you. In subtraction, always convert subtraction into addition. I will show you something. How? If I say, for example, gentlemen, A minus B, you just consider it as A plus negative B.
So you flip it out.
Yes, this is much more easier for you. Really, wallahi ya shabab. So what? This is A, this is B, this is negative B, right? We just flip it. So you have this one and this one, you just draw it. For example, send B here, تعالوا ارسمهم هنا. This is negative B. And finally, my final answer will be
A plus minus.
A plus minus B. Right. This is the answer. How is it comes? So this drawing, we are not asking you to draw. In the exam, by the way, they will give you these two vectors and they will ask you something of that. This is the idea. Now you've seen some questions. I will show you some questions. This topic is very important. Always we pose some questions on this. Look at this here. In this question, which is here, which of the vectors in the second row shows 2a minus b? If I say, what is 2a? Draw 2a minus b. Who can tell me what to do? We need to find 2a minus b. I will make the first step. We consider 2a plus negative b. Yes. Yes.
Roll double A.
Yes, أول حاجة we double A, right? I will double A. This is A, I will make it double. Yes, this is 2A. Then what to do with B?
Opposite.
We just flip it. B راح نفلم كده. حتى نوصلها we just do it what? Like that. Is that clear?
Yeah.
Okay. Now we have 2A. So your answer is gonna be like that. From here to here, this is your 2A plus my negative B. So, by the way, you are not going to draw, but there will be some options for you. Which is the option?
A.
A.
Yes, it is A. Is that clear why it is A?
Yeah.
Well, it's impossible for it to be B or C or D. So the answer is A. Did you know how many form of this I can change it? Or what? This is the idea, Shabab. You know the idea, not I can make it minus 2A plus 3B, minus 2A minus 2B, whatever is it. You just do the here, the option
Understand the
with a
idea.
pencil. You do draft and draw it and you just simply recognize which is the original or the correct answer. واضحة بارك الله فيكم. This is it. طيب يا شباب. Now let's go back here. This is the last point. This is we call by decomposing of vectors. Decomposing of vectors in Arabic بنسميه تحليل المتجهات. It means you split the vector into horizontal component and vertical component. سمعتوا عن شيء اسمه المركب السينية والمركبة الصادية يا شباب؟ أو المركبة الأفقية والحاجة. Okay, what you have? You have a vector A, for example. خليكم معي شباب. If you have a vector A, this is just like this one, you can draw your own coordinates for it. نرسم احنا وياكم إحداثيات الأفقية اللي هي X والعمودية اللي هي Y. Okay? Always we consider the following. The projection of A on X-axis, مسقطها على X-axis, this we call by the horizontal component. نسميها AX. And the projection of A on the Y-axis, we call it by AY. Okay. Now, why we have here? This is here. This is we draw just like we call by a parallelogram. كل ضلعين متوازيين يا شباب. This is AY and this is also AY. This is AX and this is also. If we consider this triangle, إذا فرضنا إحنا وياكم this triangle, this is called by right angle triangle. So we can apply what we call by Pythagorean theorem, and we can apply also trigonometric rule also. trigonometric يا شباب اللي هو قوانين الساين والكوساين. Suppose this is theta. ذكرونا انتم بتعرفوا هذا. قانون الساين ثيتا
Y over R.
it's opposite over hypotenuse, right? المقابل على الوتر. لازم تعرفوا هذا يا شباب، هو مهم. وعندنا الكوساين ثيتا is adjacent yes hypotenuse. Finally في عندنا كمان شيء اسمه tan theta is opposite over adjacent. Okay? تعالوا معي. In the same manner we have for this theta I will write the following. If I say for example sine theta which is the opposite here opposite AY over A. Cosine theta
AX.
بارك الله. طيب if we do some cross product here اضرب وسطين طرفين.
Sin A.
أيوة. You should know that AY equal A cosine
B.
و AX.
Equal
طيب. In other way to make it general, always the adjacent is cosine. So the other one will be sine. This is not actually here. We can't say this is always fixed. We can change it. بس تعالوا يا شباب. This is here theta. If I say this is AX, so AX will be cosine, and AY will be sine. If I give you another here, if I give another angle, suppose this is alpha. For alpha AY cosine, and AX واضحة الفكرة ليش؟ ألفا مين مجاورها؟
AY.
راح أكتب هنا يا شباب AY بارك الله يساوي A. لاحظوا يا شباب كوساين مش ثيتا كوساين ألفا والAX يساوي A ساين. ما هي واحدة كوساين والثانية ساين على طول. Always adjacent is cosine. Okay؟ طيب. Till now, is it okay for you? أنا بس نحل هالسؤال أنا وياكم. Come on, Nathan. Here we have the following question. What are the x and y components of a vector C? You may ask yourself, oh, what about the vector C? How is it? Don't worry. Draw your own components. ارسم من عند التيل دائما نرسم. راح ارسم لكم اياها. انا عندي هذا y وهذا. طيب يا شباب. البروجكشن هنا عد 1 2 3 صح؟ بس لانه to the left راح يكون minus. اوكي؟ طيب البروجكشن هنا يا شباب 1 and 2. This is 2. بس وين؟ So the answer will be it's okay? طيب. Now I need someone to answer this question for me. What are here? You have a vector. That vector has 4 units. Okay? This is given here. Suppose the vector is F. Stands for force. I need Fx, I need Fx and Fy. يلا يا شباب. بس اعطينا خليط. انا بعطيك هذا. ما يبغى له على حاسبه. Yes.
X is minus 2 and Y is minus 2.
Give me the equation. اعطينه معادلة. صح X is minus بس انا بدي اعرف كيف طلعت هذا. This is what I'm looking for. أنا ما عارف من هذا. Who knows from back side؟ يلا يا شباب ارفعوا ايديكم تتنشطوا. سهلة. شباب هذه اليونت هذه الانجل مين الادجيسنت لها؟ واي ولا اكس؟
واي.
إذا واي ايش نعتبره؟ ساين ولا كوساين؟ ما هي صعبة. اوكي؟ والاكس ايش نعتبره؟ ساين. واحدة كوساين على طول الثانية ساين. اوكي؟ تعالوا معي هنا. الاف اكس راح اكتبها 4 ساين 30 4. اوكي؟ في عندنا معلومة. طبعا هذه بتطلع يا شباب 2 هذه تطلع رقم. ما انتم عندكم على حاسبة. we have to stick with the signs of each quadrant. احنا يعني بمعنى اخر يا شباب انظروا انت عملت الاكس والواي لك صح؟ هذا الاكس انت راح تروح لليسار اذا ايش بيكون؟ وراح تروح هنا لفوق ايش راح يكون؟ بوزيتيف. يعني شباب مو ضروري دائما يجيب لك الزاويه هنا. يعني مثلا يقول لك الزاويه ممكن يغيرها كما يشاء هو. فانت بتعرف always adjacent we consider to be cosine and x. So you will see that the answer is like that only. Answer is -2 and 3.5. -2 because sine 30 is half. Half times 4 is 2. But it is to the left side, so it is -2.
Can we use calculator in the
Yeah, of course.
physics exam?
It's allowed. Yeah, it's allowed calculator. Okay, Shabab? Now, last point. خلاص أنا عارف إنه راح تسألون منين يا دكتور أجت هذه الأمور كلها اللي تحت. بس نوضحها. Now we use Pythagorean theorem. See يا شباب. We say this is your vector. Suppose it is A. Now, if we consider this is AX, we say this is A, Y. This AY, this is also AY too. We consider now, this is a right angle triangle, as I told you. We know from the here, Pythagorean theorem that the square of hypotenuse is equal to the sum of the square of two other sides. So what we write A square, هذا هو hypotenuse is equal to ax square plus ay, or we can say a is equal to square root of ax square plus ay, which is this formula. Also, we can write here tan theta, if this is theta, is equal to what? Opposite over, so it is ay over, if we send tan to the other side, it could be tan inverse, shift tan, الآلة حاسبة. So theta will be tan inverse of ay over, and this is the formula. Same thing that we use it here for c, cx, cy. You can say fx, ax, ay, bx, by. Same thing, okay? So this is the idea, Shabab, we understand. Allah Ibarak, be done today. You can, please, you revise it at home. Allah Ibarak, راجعوهم يا شباب. Today's lecture is very, we can say, it's a basement background for what we take later. We will use this in forces, in acceleration, in many things. That's why it's important to know these. Okay? Right. And بس يا شباب 27.
نقدر نشيك على